Okay, hello everybody, and welcome to Lambda Lounge for October 2021. Yay! So I'm Connor, I'm one of the Lambda Lounge organizers, and today I'll be talking about Clojure, or more specifically, type Clojure. So I guess the general theme is what can we do to make Clojure a little bit more type safe? Because if you use it, it isn't. So without too much ado, let's get started. Okay, I'll make the presentation a bit big. You don't need to see my face. You know what I look like. Okay, there we go. Right, cool. Okay, so here we are. Let's just get through the housekeeping type stuff first. So if you want to join our Discord, use that QR code or click the link. We'd love to have you there. Feel free to make comments on Discord, and I might see them. Or I might not. It's in a different window. Otherwise, you can always make comments on YouTube, and I can see those. I'll pop them up on screen, and you can ask me questions that way if there's anything that you're not clear on. Cool. Okay. Right. Let's get into it. So hopefully most people watching this will be familiar with Clojure. If you aren't, well, I'm going to tell you. So Clojure is it's a type of Lisp, I suppose. It is a hosted language. Mostly JVM, but it does do JavaScript as well, some other stuff, like the common language runtime, if you want to do some Microsoft type stuff. Lots of cool features, actually, if you haven't used it, so it's definitely worth checking out. Really good for data processing, stream processing, that kind of stuff. But I guess the major reason we're talking about today is it is a dynamic language, and that also extends to the type system. So let's just kind of explore that a bit. So dynamic language, or dynamic type systems, I guess. Well, yeah, let's talk a bit about dynamic languages first in general, I guess. So the major benefit to me of Clojure is that it's pretty dynamic all the way down. So if you want to, you can start up a REPL and kind of develop things interactively, change things, all kind of stuff. You can modify a running system by just connecting a REPL to that system, and yeah, it's really flexible. You can even connect it to a production system and change the code there. Although it might not be such a brilliant idea, but you can do it. It's fun. So it's got lots of flexibility, and the type system in Clojure is also flexible in that it's dynamically typed. So you can do more or less whatever you want. Data in Clojure is it doesn't put a shape on it. Let's put it that way. So there's this distinction, I guess, to draw between curry types and church types. So let's put it this way, I suppose. Stuff like Java or Scala would be using church types. So there's the types are kind of intrinsic to the whole language. There's no such thing as you can't use language without types. It doesn't make any sense. Whereas curry types are more extrinsic, basically. So you don't need to pass any kind of type checker to make things work. It'll do whatever it wants, and it'll try its best to do stuff. And here's a diagram I stole from Lispcast, which is really good. So you should check it out. So basically, if you're looking from the church angle of types, you got the universe of well-typed programs, and then the subset of that is untyped programs. So in other words, you could think of it as a Java program where it just uses object, or the any type. Basically, if you think of a Clojure program in church terms, you're essentially it just has any type. There's no restriction placed on it. And then if you think of it the other way around, from like curry types, then you got the universe of dynamically typed programs. I mean, basically, there's all programs, not the ones that could exist. And then the subset of that is the ones that you run through a type checker and check for type errors. So they're both valid views. Neither one is correct. They're just different ways of looking at the same thing, really. So that's the theoretical background, I guess, if you want to think of it that way. Okay. So let's just do a little running example that we'll be talking about through the course of the talk. So we want to store data about employees, which is something that every company loves to do. They store all sorts of stuff. Yeah, but I just picked employee because it was easy to think about and fairly common. So, okay. So an employee has 4 pieces of data that you might want to care about in this model of the world. The person's given name, the person's family name, when the company employed them, and where they work. So you can see here 2 things side by side. So I've just done this one on the left in Kotlin. So this is a data class. Basically says the employee has 4 pieces of data: given name, family name, date employed, which is local date, work locations, which is set a string. Although actually, if you think about it, some cultures don't actually have both given name and family name. So, again, at the first hurdle, we've kind of fallen down a bit. But never mind. So the Clojure model of this is most data in Clojure is just load of maps. That's the data. And that's just how Clojure tends to represent things. And in case you haven't come across it before, the keyword in Clojure is like this thing with a colon, and then they use lowercase with dashes in it. So give a name, family name, date employed, work location. So that's basically what the deal is there in Clojure. So there's no, like I said, there's no structure based on that. It's just a map with data in it. So yeah, we'll see what that means in a sec. Okay, so what happens if we try to get something that isn't there? Well, the good thing, I guess, about having a static type system is that you can't. It can't happen, or at least in Kotlin it can't happen. In Java it's a bit more subtle, but in Kotlin, if the type is string, that means the data is always there and always null. No, it can't be null. It can be a blank or empty string, sure, but it can never be null. Yeah. So if you do employ that given name, there's no chance of something weird is going to happen unless the JVM completely falls over. But well, it's a bit different in Clojure. So if I define an employee looking at that, get this map, and I try to ask for the given name, well, I'll get nil. So yeah, Clojure will try and do nice stuff generally if data isn't there. So it'll say well, it wasn't there, so here you go, you get nil instead. Too bad. So that's something you have to keep in mind, I guess, when you're writing Clojure programs, and kind of be defensive, I suppose. The data that you pass into a given function probably looks the way you think it is, but maybe it isn't. So you have to handle that. Cool. Okay, but let's see. I mean, what if we want to try and bridge the gap between the two worlds? There's loads of different ways you can do it. So I'm not going to go into any of them in a massive amount of detail, but let's start with the, I guess, simple ways of doing it. So Clojure lets you define types and records with the def type and def record. They're probably macros actually, but I'm not sure off the top of my head. So the two are pretty similar, I guess. The difference is, if you want to think of it this way, that kind of def type gives you like a kind of bare object. It doesn't have anything really terribly useful in there. Like it has one constructor and some fields. That's about it, I think. Whereas def record is a more batteries included kind of thing. It's more analogous to, say, the Kotlin data class. So it has equals, hash code, or useful stuff basically. Cool. Okay, so you can see the syntax here: def record, employee, and then you tell it what are the fields that the employee has. Given name, family name, date employed, etc., etc. And then if we can define a function, make employee, and then this syntax with the arrow employee is how you that's calling the constructor essentially. And then we can call given employee, and ta-da, we got employees. So, we got the structure. So it has like a shape. So the data, if you have a function that is expecting an employee, then you can have reasonable certainty about what the data ought to look like. But it doesn't stop you from doing things wrong, unfortunately. It doesn't enforce it. Let's put it that way. But what if we do want to enforce things? If we do want to make sure that, if I call a function that's expecting a string, that the data coming in is a string, or a number, or whatever, basically. So here's some potential options that you might want to choose in your program. So I'd say I've not used any of these in a massive amount of detail. I think I've used Spec a little bit in Anger. So if anyone's used those in a real, in quotes, getting paid for do this stuff type way, then please let me know. That'd be really cool to hear about. But I'm just going to give you my impression as a mostly outsider here. Okay, so let's run through them for a bit. Cool. So Spec. Spec is, I believe, the brainchild of Rich Hickey, as far as I know, who's the creator of Clojure. So it's part of core Clojure itself. You don't need to, use any libraries for this one, but it is still alpha. And to be honest, I'm not entirely sure what the story is with the Spec. It's a bit of a strange thing, I think, because it's been in alpha for quite a long time. And as far as I know, it's going to be replaced by Spec 2 because something was wrong with the design. And maybe maybe reading the slides ahead, you can spot what it is. Anyway, so yeah, at some point it'll go to Spec 2, and you probably have to change all your code if you use Spec 1. But presumably they'll think about it, and the migration path won't be too bad. So how do we use it? Well, just require the function, and then you can do you can ask basically, does a value match some predicate? Using the conform function. If it does, super. We'll return it. But we can also check whether something is valid or not using the valid function. But to use any of these specs, basically, we have to register them using sdef. So the way the specs are named, it's generally keyworded, and there seems to be kind of a not quite commandment, but certainly a strong expectation that all of your specs will be keyworded in a certain way. So if you've got a spec for the employee's date employed, we keyword it as keyword employee / date employed. Inst means is this instant? Cool. So let's try writing a spec. Let's give it a go. What does it look like? So we defined specs for the given name. It's a string. Family name, also string. Date employed, etc., etc. Work locations is a collection of string. So that seems pretty straightforward. Seems right. So then that's the specs for the individual fields on the employee. But then if you want to define a spec for the employee record as a whole, we do it like this: sdef employee / employee, which I guess that makes sense. I guess the keys of, and then you give it the specs you've already defined. So then you can use sexplain, passing in some data, and it'll tell you if it failed or not and what's gone wrong, basically. So you can see that this employee got a given name, nothing else though, so that's a bit useless. And it'll say, you failed. There should be a string. Family name wasn't there. You failed. So go away and think about what you did. Okay. So we can use this in functions as well if we want to define what functions ought to do. So you can see we're defining the employee name function, and the purpose of this is to get the employee's name. I bet you didn't guess that one. So you pass an employee, and then you can see here we're doing let e. So we assert that the employee matches the employee spec. In other words, that it's valid. And then this is just the bit to get the name out. Slam together their given name and family name. But again, wouldn't work for Japanese people probably. But anyway, never mind. No one's paying me about this code, so that's fine. Okay, so I guess the thing you probably noticed is that this is not happening automatically. You have to do something about this. You don't get this for free. You only get this at runtime. It's not compile time checking. So you can write wrong code all you want and only find out that it fails at runtime, which is it gives you some certainty, some level of assurance that your data is right, but you do have to work to get there. And you can transform data to make it match your spec using conformers if you like. So if something isn't quite right, like so say something is a number and you want to turn it into a string, you can do that using conformer, for example. But if you want to define specs for your complex data types, like say you've got some kind of data structure with nested data, and the nested data has another nested item inside it, or it has a collection of nested items or something, these specs, in my opinion anyway, they get a bit verbose, a bit gnarly, a bit hard to understand. Not super keen on spec, let's put it that way. You can use them on functions as well. So if we've got a function that doubles x, It multiplies x by 2. Well, that's fairly easy to understand. But if you want to define a function that checks that the input and the output is correct, it looks like this. So, yeah, well, you can see it looks a bit weird, basically. It says, the argument should be an int coming in, and it should return an int, and the function should do this. It kind of describes the relationship between the input and the output. But I don't know about you, but I find it hard to understand and a bit verbose. I probably wouldn't. I wouldn't be terribly keen about writing these functions because you'd have to change them every time your code changes as well. For non-trivial functions, that might be unfortunate. Cool. Anyway, let's move on to the next one. So Schema. Schema is not being developed anymore, as far as I know. I'm not entirely sure why about that. I think it's because the assumption is that Spec 2 will come out, maybe. It only works with Clojure 1.8. So if you got Clojure 1.9 and 1.10, which is recent Clojure 1.10.13, I think. Not entirely sure. You're out of luck if you want to use Schema, I think, as far as I know. I mean, it might still work. I haven't tried it, but it isn't officially supported. Let's put it that way. If you use Clojure script, it does work with more recent Clojure script versions. So let's see how this works. So let's compare it to Spec, I suppose. So we require schema core, and we define a schema for an employee like this. So we have employee schema, has a given name, which is a str, means it must be a string. Family name must be a string as well. Data employed must be an instant. And work locations, you can see here the square brackets must be essentially a list of strings or a sequence of strings, I think. But I quite like this approach in that it looks very like the data it's describing most of the time here. There's obviously some edge cases and bits, but in general, if you look at that spec, you think, it's for an employee. I can see all the keys. I can see what they map to. That's quite nice. Yeah, that's good. So we can can validate employees and throw an exception if they aren't right. You can check whether they're right or not. You can write your own matches as well, which is quite nice. You can actually wrap functions as well using sdefn, and you can wrap variables using sdef. So you can kind of they're sort of like type-ins on fields and arguments and things. And then anything wrapped with sdefn, you can enable validation, runtime validation, globally in your namespace or in your REPL session, or if there's some like really important function that you want to make sure is absolutely right all the time, you can enable that for some functions all the time. But obviously, it is runtime validation, and you have to pay a cost in terms of performance, which is that's just the way it is. So you can also transform things, coerce them from one type of data to another, like the same thing as spec. You can turn a string into a number or vice versa, which is again nice because you don't transform it separately, which is good. So you can kind of do a bit of the data mangling inside the schema. But if you want to try and do more complicated validation, like say an object has field A must have field A or field B or both of them, then that kind of thing is more difficult to express. It's not really set up to express things in that kind of way. It's more about describing the shape of the data, and any kind of, let's say, maybe higher order type concerns like business validation of that type is more difficult to get done. And if you want to validate sequences and stuff, like say, this must be a sequence of objects, each of which must be, created on last Tuesday or whatever, then that's not as easy to do as spec. But schema in general, I mean, I like it. People seem to use quite a lot, or have done here. I'm not sure whether they still use it, given that it doesn't really work with latest Clojure, apparently. We'll see. So let's move on to the next one, which is Malli. So Malli is, as the name you can probably guess from that, developed by a bunch of Finnish dudes, I think. So it's an alpha state, but it is an active development, and the developers are very responsive and stuff. So I mean, I wouldn't be necessarily put off by alpha, especially given that the Clojure community as a whole seems to be well down with alpha alpha libraries. But I think the alpha state is just a warning that the APIs may change. So if you decide to use it, just caveat emptor. You might need to do some work to update your Malli version. So let's see what this looks like. Right, so we require Malli core. We define an employee, which is a map of these things. So it's basically like give a name string, family name string. So there's a distinction here between these two. I don't know whether you notice this, but string question mark is a predicate that says this predicate will run on the data and check it's a string. But for common ones, I think you can also use like a keyword. So this keyword string, just basically it's the same as string question mark, but just it's almost everybody will want to do checking that some field is a string. So that's a nice feature, I guess. Data employed inst work locations sequential strings. So it's fairly clear to read at a glance what's going on here. I think it's pretty good. Again, you can validate things, and you can use any function you want really as these validator components. So if you want to define your own wacky predicate that does a million separate things, go ahead. It's fine. It's totally fine. You can use your business validation function there. Yeah, no props. So you can also transform values just like the other two, but it's pretty good at it actually. So Malli, I think its whole selling point is that it's a more data-driven type thing. So I'm not sure what Malli refers to them as, but like the schema equivalent or a spec equivalent is something. It's an object that you can then further transform if you want to, pretty easily. I mean, it makes it easy for you. I have to say I'm not 100% sure what the use case for changing the validation for a given data type on the fly might be, but obviously if you're using it to validate something, it might be useful. Anyway, see, let's have a look at the transformer. So you can use encode to change things basically. You can look at this key transformer encode name. It basically encodes the keywords give a name to a string give a name. So that's this something you can do. You can turn them to JSON. You can turn them from JSON. It's pretty good for transforming data. That's quite nice. And of course you can compose them together if you want to. Okay. I skipped ahead of myself. But there you go. Schemas can be used as data. So you can write them as Eden if you want to. They're completely serializable. So you can serialize them. Store them in a database, load them in that database, etc. No problem. You can see here that if we got an address, not address, that should say employee. That's a typo. If you got an employee ID that needs to be added on, you can add it on to the spec, and then from then on, any further employees must have an employee ID to be valid. So that's quite nice. You can do any kind of programmatic transformation if you like. There's lots of tools that let you do that. You can merge them together if you want to have some kind of super objects. That's the kind of composition of two or more separate ones. No problem. You can draw them as UML if you really love UML. Lots of different stuff. And it's actually a really nice feature. I quite like this one. If you give us some examples of your data, it will try and infer the schema for you, which I think is quite nice. If you're kind of trying to bootstrap this stuff and you want to get off the ground, you can say, well, my data looks a bit like this, and it'll try its best to say, well, the example you've given me, this is always a string, so we think it might be a string, that kind of stuff. So that's quite cool. So just like to present these in a table, I guess. Pros and cons. So Spec, it's got a centralized registry of specs, which is makes sense to me. It's kind of the analog of a type system, because if you have an employee type in your Java code, then obviously with caveats about packages and stuff, but that employee type is fairly universal. You can use it for generative testing, which is nice. There's quite a strong focus on using Spec for that. So kind of fuzzing or property-based testing, whatever you want to call it. And it's part of core Clojure, so you don't need to draw in any libraries. It's probably going to be supported pretty well. That's quite good. The downside, it's still an alpha, and something isn't quite right about it. I mean, it's going to be supplanted by Spec 2 soonish, maybe. I mean, Spec 2 itself has been an alpha for quite a while anyway, so who knows? Watch this space. Spec feels quite complicated to me here. I mean, maybe it's just that I haven't used it enough, but it feels a little bit heavyweight for what you get. And also, it's a bit slow in the runtime performance penalty is you probably notice it, I guess. Schema, I mean, I really like the fact that it matches the data that you're validating. They look quite similar. I think that's a nice feature. It's easy to set up, but it's not being developed anymore, as far as I can tell. Unless somebody's forked it, and I don't know about it. It's pretty going to be static. So if there's some killer feature that you're looking for, you're probably not going to get it. And if you want to do anything complicated, it's a bit tricky. So Malli, it's cool actually. Data-driven schemas is cool. It's a cool idea. You can do lots of nice things with it. You can serialize things. There's lots of batteries included type stuff, which is nice. It's faster than Spec, which is good. But downside, still an alpha. I wouldn't see that as a big problem. But you are probably signing up for a bit of work to change things. And once Spec 2 comes out, it's probably not entirely clear which one's going to win out eventually. So you might need to chop it entirely and change the Spec 2, maybe. Anyway, so that's the pros and cons of those kind of runtime validation type library approaches. So let's take a little side trip into Clojure-kondo. So Clojure-kondo is actually a really cool tool. If you haven't seen it or used it, you should probably check it out. If you use Clojure, it's like a linter. This guy called Michael Borkent, I think his name is, made it. So it kind of can validate a whole load of stuff about your code. So I think it's probably more full feature than Joker. I think that was the other linter I've used before. So it does lots of cool stuff. So it's really nice. But apart from all the other useful stuff, you can also do type inference, which is not something I would have expected in a linter, but you can do it. So I think this is still kind of early days type stage, but it's it does work. So some of the library function in the Clojure it knows about. It knows what they should look like. So if you do ink, for example, I think it'll say, oh, you meant to you passed in a string to ink, but it should have been a number, that kind of stuff. If it can work it out, which is quite nice. If you got some type hints on your code. Like say you've type hinted employee name to be a string, and somewhere in the code you can see that you're passing in something that isn't a string, then it'll say, whoa, hold on a second here. You said the type hint is this, but it should be that. It'll tell you about that, which is cool. And you can actually also define the, the input and output for functions. So you can do it in the configuration for the linter, but I'm not totally sold on this syntax. I mean, namespace my namespace, my function. For an RT1 version of that function, the arguments come in a string and it returns a string. I mean, you can understand it when you read it, but it's not exactly easy to parse at first glance, perhaps. But it is cool, and it definitely is a nice halfway house between or a supplementary measure perhaps as well. So I would probably say that it's a good thing to try it. So the kind of the more fully featured or extreme perhaps version of that is type closure. So I bet you're all waiting for this bit. So basically type closure is different than those other ones. So it's not a runtime validation type thing. It is a compile time thing instead. So if you've used Racket, you probably will know about type Racket. So I believe it was inspired by that. I think his name is Ambrose Bonaire Sargent, I think. So he did a PhD thesis or a paper or something like that about essentially doing this stuff. And he's kind of been working on it ever since as like a library. So basically what this does is it uses static types that we've only got at compile time to reason about how things should behave at runtime. So the runtime, nothing has a static type, but they do have a tag. So you can kind of reason about invariants. So I'd urge you to read the paper if you want the background, because it's quite an interesting read actually. So it's JVM specific for now. I mean, there is some moves towards using a Clojure script, but not yet. So if you want to use this with Clojure script, well, you can't. Sorry. So it basically leverages the JVM top checker, and it's a separate step. So it's a separate step to actually compiling Clojure code. So let's see a little bit more about how it works. So basically, what we do is we annotate vars, we annotate function parameters. In the same way as if you're writing a Java program, you're saying, yes, my method takes in a string and returns a string. It's the same concept, so it's not not difficult to understand, I think. So CF is a function that it takes a form and a type option, and it returns a human readable inferred type. And if something goes wrong, it goes, whoa, that's an exception. So basically, we're saying here, annotate employee ID with a number. So this employee ID is a number, it must be. And then if we define employee ID 1, yeah, cool. Yeah, it's a number, great. And if we check what employee ID type is inferred to be, yeah, number. Well, that makes sense, cool. And you can, again, with your functions here, you can say, the ID, this little, if you turn your head to the left, it looks like a little face to me, or maybe something else if you turn your head to the right. This basically says ID should be a number in this function. So, you can say, oh yeah, the function is a function of number to number, and these things then TT else if. So they are filters, essentially. So TT is trivially true, and F is false, basically. Always false. So basically, you can provide bands and types just like you can in Java. So you can provide must extend string, whatever, or must be supertype string, whatever. If you really want to, you can do higher kind of types. I bet you weren't expecting that. If you want to do some monadic closure, I'm not entirely sure if you want to, but you can do. So let's see how it works with the employee that we had earlier. So let's annotate this record. It has a whole bunch of functions that let you annotate various things. So the employee given name is a string, family name is a string, date deployed is local date, work locations is a seekable string, in other words, it's a sequence of strings. And then if we have a function that takes employees in, like our employee name function from earlier, we can say, yeah, employee name, the employee variable that gets passed in is an employee, and it gives you out a string, and then you write your implementation. That's quite cool. It seems fairly straightforward from that point of view. Well, let's look at the pros first. So if you statically analyze your types, then you can completely remove certain types of bug. In other words, there's if you say that this function takes in a string, there's no possible way that it can take anything other than string, provided you've analyzed everything and the type annotations are there. So there's no need for runtime checks, so that's good. You're kind of pushing the pain to the compile time. You don't need to have the runtime penalty. There are integrations to Spec and Malli if you want to use them. It's still in development. It seems like active development to me, but the downside is it's still in development. So that's it's been going for at least, I would say, at least 6 years, I think, and it's still in development because it's not easy to kind of build a static type checker onto Clojure. It's not very fast. In fact, it's quite slow. So the only people I know of that use this in anger in a serious way were Circle CI, who is a CI/CD platform provider. So they write, as far as I know, most of their code in Clojure or Go. But the Clojure bit, they use type Clojure quite a lot. But if you search for Circle CI type Clojure on your search engine of choice, you'll find that they gave up using it because it was just too big a hassle, which is maybe not a great sign, I would say, because basically it makes it hard for you to write code, because it's probably, I guess, the same thing as trying to appease the borrower checker in Rust, or trying to convince that yes, this is really, really, really true. Not all core Clojure functions have got type annotations, and external libraries almost certainly won't. So you might need to jump through some hoops and things if you want to appease the dread god of the type checker, which is a bit of a pain. And so I think the two major things that Circle CI complained about were it was incredibly slow to do type checking. I mean, to be fair, this was a few years ago, so it may have gone faster since then. But the kind of quoted figure was, I think, 2 minutes to do type checking, which kind of really really messes with your kind of REPL-driven, fast, interactive type flow. It's not going to work too well that way. And also, I think that another big complaint was that you do have to write a code in a particular way to kind of make the type checker convinced that this is going to work. And of course, it's JVM only. So if you're trying to use ClojureScript, well, you're out of luck basically. Yeah. So I suppose just to kind of give an overview of if I were kind of starting a project from scratch and I want to do something, what would I do? I probably would use Malli. I think Malli seems like of the options there, I would say use Malli. It seems like a winner to me in that it's being actively developed. If you go on the Clojure and Slack, the Malli channel is pretty active. They do, they're pretty responsive and stuff if you have questions about things. The feature set seems good. It seems well thought out. I like the data-driven nature of it. That's so cool. And I probably would, supplement it with Clojure-kondo as a backup, I guess, to catch up with stuff. Cool. Okay. So that's pretty much it. That's all I want to talk about, really. So if anyone has questions, this would be a really good time for it. I'll pop them up on screen and try and answer them. Although I can't guarantee I'll be able to answer anything. But fire ahead if you have any questions. Unfortunately, there's no one else to talk to, so I'm going to have to talk to myself to fill the dead silence. We should say as well that if anyone wants to come on Discord, you're very welcome. It's always really cool to see new people there. So if you haven't joined our Discord server already, that'd be really nice. You can talk to all our speakers and things. They're usually there as well. So that'd be cool. And if anyone wants to speak, that would be really good. I think we have a talk lined up for next month about systems thinking or something like that. I think I don't remember the details, but it should be really good. Before Points Beyond, if you have any ideas for talks, then let us know. We're always really happy to have anyone speak. This is usually a really friendly crowd. So yeah. Okay, so it seems like no questions. So obviously I've explained all of your points. Cool. Okay, great. So yeah, that's it for today. So I hope you all have a good evening, and I will catch you all next month. So yeah, see you guys.